So now that we have some intuitive understanding of the scope, we have to make sure that it's working before we begin. And these are things that should be done, every day before you begin work. Because honestly, the probes get abused in lab, um, which is probably the number one source of errors. And people can ruin a probe and then put it back and not tell anybody. So really, you should be doing this every time. Now the thing is we have a nice waveform generator, but there could be a problem with that as well. So what we do is we use a signal generated by the oscilloscope to test the oscilloscope. So we have a ground here, and we're hooking up both probes to a square wave generator. I've turned it on, I've hit auto set, and it looks like, everything is fine, right? Let's just look at this in high res mode. Alright, so now it's in high res, and let's see if we can mathematically see how we're doing with these waveforms. Alright, so let's go to, we'll do menu off, math, and it's already set up between 2 and 1. We're on divide. We have add, subtract, and when we subtract them, it's not 0, right? So, and it looks like noise. So I have to see, the scale here tells you 50 millivolts per large division. So it's quite small, right? But it could be detecting things elsewhere, right? We could try it, but that's probably within spec. And of course you want to see multiply, that's multiply. But doesn't mean we're done yet. So we're going to hit math twice. That turns it off. And I want to zoom in on these waveforms. So I'm going to, that's the scale. I'm going to move waveform 1 down, waveform 2 down. All right. Now, you'll notice while I was working with the scale that we lost the triggering, right? Is because there's not enough resolution to detect it. So I would have to increase the scale here to detect that. All right, so anyway, things are now good, and I'm going to try to show you about calibration. Now we can see at the bottom they're different, and it's not an actual square wave. It's got some issues with the corners, right? So I'm going to zoom in on the time, right? That's over here, right? And you can see there is some issues with that corner, and they're not the same. Now, the thing is, if I zoom in anymore, it goes kind of off the screen. There is something called horizontal position, right, where I can move that, more into the center. All right, now I should be able to zoom in on time a little better, but that looks to be about as good as it can be. So you might not understand the theory, but there's some capacitors in there, and that can get, let's call it uncalibrated. And so we want to make sure that this edge is flat, right? And you can see that, and so there's a screw in here. Let's see if I can do it. and talk at the same time. Okay. And so if you twist the screw, you can see I've just made it worse, right? I can go the other way, and I've made it worse the other way, and I can just get it flat. I'm going to have to look at the... So, and it looks like I can't really get it. Like I have an exponential decay that way, I have it the other way, and I'm just going to have to split the difference. Okay? And then I'm going to move over here. I'm going to just turn that waveform off by pressing it twice. Just let me... Okay. So I hit something. So if I twist it one way, bad, twist it the other way, it goes the same kind of bad. Let me just... So there is this little dip here, but then it's flat. See if I can turn this off. Here we go. All right, and now I'll go to auto set. All right, I'll turn on both waveforms. I'll go to acquire mode, high res. I think that's as good as I can get it. But let's see if we can go to math and subtract. Okay, so it's the scale is not 50 now it's 20. It's more regular, right? But there is a slight difference. Let's see if this helped the FFT. No, not the FFT. Oh, it would be the, if there was a sine wave, it would be the multiplier. A little bit harder to see, but there was a curve downward over here. Now that's gone away. What we can do is pause and go back to our sine wave to see if that's better. Alright, so I went back to the sine wave, but I made it 1 volt peak to peak just as a refresher. I just enter in a number and then I choose the units and it'll set. So now that I'm looking here, right, it does look a little bit better, although this is kind of on the grid and the next one is a little bit below. So I'm still seeing that. Let me reset the function generator, because the improvement might have just been because I made a larger peak to peak. Alright. And we'll auto set. Alright, the noise is back. We'll go to acquire mode, high res, and yeah, it actually doesn't look like the probes were the source of the issue. Just having a smaller amplitude. All right. So if we could just, to experiment, we could enter into peak to peak. Right, come over here, auto set it. Still seems to be there, but it never. These errors, never go to 0. Okay. But let's just to compare, we'll go to acquire mode high res just to see it. Yeah. So another thing we can do to check is XY, and we'll turn math off, and we go to acquire XY on. And it's a straight line, but I'm not quite sure where 0 is, so I'm going to go back here and set everything to the same cross point. Make sure that the offset is 0 over there. Acquire. Okay, there, now we can see that better. So now it looks like, V out equals V in. There should be a slope of 1. Let's see if I can turn on the cursors, right? So I just turn on the cursors here. The button on top moves the square cursor. The knob on the bottom moves the bottom cursor, and you get X and Y. X and Y, that gives you two data points of a slope, and you can, how close are we to 1, right? And you can get that. Now, does it go through 0? What you do is you zoom in on your axis, and we're getting a little bit of hysteresis there. So let's go to average. It'll take some time. Actually, that's very close to 0. That's a lot better than what I was getting yesterday before the probes were calibrated. So just to sum up, right, when you come in, you should connect the grounds here and the inputs here to the square wave, and make sure you're getting a square wave and that it's triggered. And you can check the error in math, right? Then now you know that the probes are all good, right? Really be careful with this. You can really mess it up for somebody else. But on the other hand, when you come in, you should just assume it's been messed up, right? It's almost like a learning objective to make sure your equipment, is plugged in and all the wires work. And it's probably worth an investment to buy your own probes, right? So then once you do that, right, then just do a sine wave, right, from the function generator. And again, I can maybe zoom in. I've got all the grounds to 1, and I got all the probes and the input to another wire. That, even though this video came second, right, you should do that every day to make sure that everything is working. Same with your your other power supplies and things like that. Doing this is probably going to be on the midterm, and also on the kind of the final exam of life. All right.